Okay, so the top part is just kind of a review of the stuff that we did in the notes, but statistical inference is using the data from the sample to make conclusions or inferences about the population. The first step is to create confidence intervals. So we gather the data from a sample that we hope is a good one. We hope that the sample proportion represents the population proportion, so we center our confidence interval at the sample proportion, and because our sample isn't perfect, we create our interval with a margin of error. So, a medical researcher estimates that the percentage of children exposed to lead-based paint, adding that he believes his estimate has a margin of error of about 3%. Explain what the margin of error means. So, basically, he is confident that the true percentage of children exposed to lead paint is within 3% of his estimate. So that's what the margin of error means, is that whatever the percent is, he thinks that is within like 3% of whatever that estimate comes out to be. All right, so this next question it goes on to the next page also, but consider each situation described, identify the population and the sample, explain what P and P hat represent, and tell whether the methods of this chapter can be used to create confidence intervals. A consumer group hoping to assess customer experiences with auto dealers surveys 167 people who recently bought new cars. 3% of them expressed dissatisfaction with the salesperson. So, any ideas what the population as a whole is? Or you can do the sample first if you want.
I gotta solve it.
Well, no, you're just saying, like, what is it? So it's kind of like when we did the stuff with the W's and the H, like the who, what, when, where. It's kind of like that in terms of what you're writing.
So the population, would that be the 167 people?
The sample would be that. So your sample is 167 people surveyed. But basically, who did they survey? Like, what would the generic group of people be?
The people who bought the cars.
Yeah, so all people who recently bought a new car. So then P is the true percentage of all people who recently bought cars who are satisfied. So that's like the population proportion. Then P hat is for the sample, which is the percentage from the sample who are satisfied with their experience buying cars. So then the question of, can we create a confidence interval? We need to check the, what's it called? Conditions. So, is it independent?
Yes.
Okay, yes. So each person doesn't affect the next person. Is it random? Or do we know if it's random?
Yes.
We do?
Yes.
It doesn't specifically say, so we're not sure, so I'm just going to put a question mark there. If everything else is met, we'll go for it, basically. If not, then 10% condition, or 167 people, less than 10% of all people are buying new car.
Yes.
Yep. And then success failure, NP, so 3% expressed dissatisfaction. So that's going to be 167 times 0.03. You know what that is? Or approximately.
I'm gonna say. Hold on. I'm about to get it. Points.
You're off by 1. You carried a 1 and not a 2.
5.01.
Yeah. So 5.01, which is less than 10, and it has to be greater than 10. So no. So we cannot, basically. What percent of college students have cell phones? 2,883 students were asked as they entered a football stadium, and 243 said they had cell phones with them. This is obviously probably quite a while ago. So let's do the sample first. So who or what is the sample?
The 2,883 students.
Yep.
That entered the football stadium.
Yep. So then the population would be who?
The 243 that have cell phones.
No, the population is more generic.
Oh, the college students.
College students. So the population proportion would be what, generically?
The 208. I'll be 43 that have cell phones.
That's this one. So this one is 243 out of 2,883, which is the proportion of students at the game who had a cell phone. So more generically, this would be the proportion of students with a cell phone in general. Thought for sure you'd have a Saint shirt on today.
I was going to, but I had forgot because I was rushing this morning. Kind of.
All right, so can we create a confidence interval? So independence. Does one student having a phone affect another?
No.
So we're independent. Random.
Yes.
It could be either,
Yeah.
potentially, because we don't know, so question mark. 10%. 2,883 students, less than 10% of all college students.
Yes.
And then success failure. NP is, oh, we need to find this proportion. So 243 divided by, whoops. This is 0.084. So we do 0.084 times 2,883. Which is 242, so that one's good. NQ would be 1 minus 0.084 times 2,883, which is 2,640. Oh, 41, it rounds up. Which is also greater than 10, so that one's good. So we could do it for this one. Because nothing is like blatantly no. The random one is the only thing that could be questionable. So the confidence interval, basically what it means, or whatever, it's the statistic plus or minus the critical value times standard error. And this critical value times standard error is the margin of error. So confidence interval in symbols is equal to p hat plus or minus z star times the square root of p hat q hat over n. We'll do the next example and then we'll stop.
Okay.
Because it's not too bad. All right, several factors are involved in the creation of confidence intervals. Among them are sample size, the level of confidence, and the margin of error. Which statements are true? For a given sample size, reducing the margin of error will mean lower confidence. What do you think? True or false?
That is true.
True. And that's because the interval will be smaller. So we will be less confident. That we capture the true proportion. For a certain level of confidence, you can get a smaller margin of error by selecting a bigger sample. True or false?
False. True.
True. A larger sample size means a smaller standard deviation. For a fixed margin of error, smaller samples will mean a lower confidence.
This one is false. True.
True.
You say it false, so it's false.
Smaller samples have more variability. So we will be less confident in capturing the true proportion Alright, this next one you're going to have to think mathematically a little bit. For a given confidence level, a sample 9 times as big will make the margin of error 1/3 as big.
This one is true.
Okay, do you know mathematically why?
No.
So the square root of p hat q hat over n says if we make the sample 9 times as big, so we're going to multiply n by 9. So the square root of p hat q hat over 9n. Since this is a number in a square root, I can take it out because it's a perfect square, so it can be 1/3 times the square root of p hat q hat over n. So yes, it is true. Alright, so the next stuff we'll pick up on Monday because it goes to using the calculator, so kind of just makes sense to do that all at once. But we'll pick that up on Monday, and yeah.